Hello, everyone. Thank you for your interest in the topic of combining robotic process automation with cognitive process automation. My name is Frank Bayer. I am process consultant for cognitive automation. With me is also Stanley Vincent. He's an experienced RPA developer. We both belong to the cognitive process services team for the DACH region led by Heike Figge. This team is part of IBM's Global Business Services division. The objective of this presentation is to explain and demonstrate how digital transformation can be accomplished by combining the two automation technologies RPA and CPA. Based on a simple fictive process, we show how to combine RPA with cognitive elements to achieve end-to-end process automation. The intention is to stimulate ideas how to apply these technologies in your business and consequently encourage you to enter the cognitive space. In this presentation, we also touch on other building blocks that, together with RPA and CPA, form the ecosystem required for cognitive enterprise automation, which should be the ultimate business goal in the digital age. To understand why it is beneficial to combine RPA and CPA, it is important to first of all understand the term cognitive. The possession of cognitive skills is what distinguishes us human beings, amongst other aspects, from machines, which is why these skills are the focus of automation. Cognitive skills can be classified into low-level capabilities, such as applying knowledge to identify or classify artifacts, and higher-level skills, such as analysis, synthesis, and evaluation. The Bloom taxonomy, shown on the left, the pyramid, is a useful classification framework of cognitive skills. Whilst RPA is best at automating rule-based tasks that require lower cognitive skills, CPA by definition aims at mimicking higher-level cognitive skills. Hence, RPA covers the lower end and CPA the higher end of the cognitive spectrum, or where one has its limitation, the other has its strengths. Therefore, both technologies complement each other perfectly. The challenge of CPA is obviously the need for machine-based cognitive capabilities, which is where artificial intelligence and similar technologies come in. The need and benefits of this combined approach is best understood by looking at a generic process that takes place in some form or the other in any organization, as shown here on this slide. This generic process starts with receiving data, for example, through an email and/or through a request form. The intake of data is most likely a lower-level cognitive task that can be easily automated. Upon receipt of the data, the user has to evaluate the data and decide on which next action to take, which is the decisive step of this fictive process. Depending on the level of knowledge and the complexity of the task or of the business rules applied to this step, it is likely to represent a higher level cognitive task, which is why it's marked here in red. In case the decision is positive, the process continues by, for example, distributing data internally or back to the requester and terminates with storing the data. Both steps require most likely lower cognitive skills. Let's assume the decision is negative, for example, an initial rejection. The process could continue with an escalation and resolution step, both medium or higher level cognitive tasks, and terminates as well with storage of data. This mix of cognitive tasks has to be approached with a combined automation concept as indicated along the process steps. For the low-level cognitive steps marked in green, RPA will suffice, whereas the higher level ones will require cognitive approach. Only with the mix of solutions, a seamless end-to-end process automation can be achieved. To demonstrate how this combined approach works in practice, we have designed a fictive example of a mortgage or home loan approval process. We will show how to deploy different cognitive solutions out of the IBM cloud to automate the process. The aim is to demonstrate the principal concept that can be applied to all kinds of processes in any organization. Let me take you along the process steps. The first step is to receive the loan request. We can do this by allowing customers sending the request by email and then reading it automatically by using RPA. As an alternative, we have also set up a chatbot based on IBM Watson's conversation service to extract the request data from the chat that the customer has got with a virtual agent. Once the data is received, it has to be enriched with external data from the web. In our example, it is the sales price history of the concerned property. This information is obtained with a standard web search API that is called by the RPA application. RPA can also collect internal data from an ERP or CRM system. In this example, it's the credit history of the applicant. The main objective of the process is to approve or reject the request. The related task can be automated by involving IBM Watson's machine learning service. I will explain its principle in the next slide. If the decision has been taken, the customer will receive an automated approval or recommendation response. The recommendation response is a customer-friendly alternative to a pure rejection. The recommendation tells the customer how to alter his mortgage request to obtain an approval and then be able to resubmit his or her request. The recommendation also makes use of the capability to predict real-time the likelihood of an approval. The process terminates with an automated generation of an internal report through RPA. This table shows the request data. It consists of 7 elements, out of which 5 are provided by the applicant through the application process. For demonstration purposes, 2 additional sets of information are required. One is the house price history that can be obtained from a UK land registry webpage. And the other one is the credit history that the bank can fetch, for example, from its internal database or CRM system. As the name suggests, machine learning requires the machine to learn. This is done by feeding the machine learning algorithm with past case data that include the request data and the outcome. In this case, either an approval or a rejection. Based on this data, a model is built to predict the decision of any future request. If organizations have got past data readily available, it requires little effort to build such a decision support model. Worth mentioning is also that the model not only serves to predict the outcome of future cases, but also makes the decision criteria transparent that have been applied in the past. That may help organizations to shed light on tacit knowledge and the business rules, and if found necessary, adapt them accordingly. The model can also be used to simulate how changes to request data impact the outcome in real time, which is done to create the recommendation explained before. Let me now show you the automated process in the RPA tool Blue Prism based on 2 fictive mortgage request examples that are received per email or by email. Let me now show you live the RPA application that Stanley has developed using Blue Prism. As explained, the process starts by receiving mortgage requests by email, and we have prepared 2 examples which you see here in my inbox, and let's open one of them. And you see here the text that could look like this: Dear Sir, Madam, as per our telephonic conversation, I'm writing to you to request a mortgage loan. And here is the data described before. We have, of course, the name and the date. We have the house number, street, postcode, and the city, the address, the purchase price of the property, the requested mortgage amount, the interest rate, and the term, and the household annual income. The second request example looks similar but has, of course, different values. And the main difference between both is that the first one will immediately receive an approval, and the other one will receive or would receive a rejection, but having built in the recommendation loop, it will be altered until it has a high likelihood of being approved. We will see this in a second. What you see here is the blue Prism RPA application and the designed mortgage approval process. You may recognize some of the elements I have explained before. The sub-processes are mentioned on the top, and we will see now the robot executing step by step. I have now started the application, and as first step, the request email is received and being read out. And on the left, you see the address details are recognized and taken in. As well, on the right side, you see for example, mortgage amount and the mortgage price. The next important step is to obtain data from an external source, in this case the UK Land Registry page, where if you enter the address details, that all goes very quick, you obtain the house price history of this property. In this case, we see 4 values, out of which we pick the last 2 ones. And now the next step, important one, starts, which also goes quickly. That is to call the machine learning model to obtain an approval score, which has already been done now. And as a next step, the pre-approval document will be generated to be sent to the applicant. And we see now in a second how this works. Here's the document, and the robot fills in automatically all the data and completes the letter. And finally, the email is being sent out. And we will also see that the records or the processing history will be recorded in an Excel file for internal audit purposes, and for each process case, a line is entered. That brings us to the end of the first processed mortgage request. We now look into how the robot processes the second case. Remember, the difference is that this one does not receive an immediate approval. We go through the same steps as we have seen before. The email is being read out, all the data is taken, and then again it opens automatically the UK Land Registry page, enters like a human being would do the address details to obtain the house price history. So now the web page is opened, the address details are entered, and the robot clicks the button to send the request. Here's the results. We see the price 18 years ago was considerably lower, and with this information the robot can calculate house price history. Now it continues with the automated decision support, and you will see now on the right the approval score, and the initial approval score is 1.8, which is too high to be approved immediately. Therefore now the robot alters stepwise the mortgage amount, and you will see that after 2 or 3 iteration the approval score drops down to from 1.8 to 1.5, and then as the next steps it got the approval, and now it's generating the recommendation letter. The big difference is, as you will see, there is now a recommendation built in that the applicant should reduce the mortgage amount from 700,000 to 630,000, which will give him a most likely approval. The rest of the process is the same. We will see also now how the internal report, is being added by another case, which is the case that we just saw now, and with all the details. And also this brings us to the end of the process. To conclude this RPA demo, let's look at the outcome, the result of the process, which is the automated generated response email that you see here in my inbox. Two responses, one the recommendation and one the pre-approval. Let's open the recommendation email, where you can see, first of all the details and of course some text to explain to the applicant the content and the meaning of this response email, and attached is the letter in Word, which you have seen before. And as you see here, is included the recommendation line and of course all the details that the applicant has provided. And the same for the other response email that you saw in my inbox. As an alternative to taking in the request by email, we also have a more interactive option, which is to build a chatbot. And this is what we have done. And here you see the chatbot already working. It's a kind of virtual agent. So the client is being greeted, and the client types now in his intent, which is what you see here. I would like to apply for a mortgage. And the chatbot then answers with the appropriate question if the chatbot is set up correctly. And the applicant is now providing all the details, for example, the address, and subsequently also the house price and the mortgage value. And so first of all, the house price, and now the purchase price, the expected one, and then the other information, interest rate, then the terms, the number of years. And here, interestingly, that's the challenge of setting up a chatbot. If the answer format is different from the expected one, then you have to repeat or to be more precise. And finally, the annual household income. Again, this is all fictive data. And to round up the conversation, the applicant is asked how he would like to receive the response. And in this case, he chooses for email response. If the chatbot is combined with natural language processing software and or, for example, IBM Watson Discovery Service, it is then possible to extract the key data out of this conversation and pass it on to the application, in our case the RPA application. This is also done via API. Let us now return to the presentation and summarize what I have shown you so far. First of all, we have seen that the combined usage of RPA and CPA enables end-to-end process automation. Manual intake and completion of data, and also the high-level cognitive task of decision-making, can be fully automated. Decision-making now follows strictly the agreed patterns, which removes human bias that may have introduced process variance in the past. As a consequence, the customer will experience a faster, more user-friendly and interactive process that the company can run at much lower costs. Here an overview of the cognitive elements that have been built into the process, and for each element some further details on the technology mix applied. Most of the described technology is provided by the IBM Cloud, like the Watson Conversation and the machine learning services. They are all connected to the lead application via APIs, in our case the RPA tool. Noteworthy is the fact that we have built this demo application within a few days. How did we train the machine learning model and deployed it to be used by the RPA tool? The answer lies within an interesting ecosystem that consists of various tools and open source platforms that, if combined with the proper knowledge, allows building flexible and high-performant cognitive solutions. We used the IBM Data Science Experience platform as development environment for the machine learning model, taken from the IBM Watson library and Apache Spark as the computing framework. After deploying the model, an API on the IBM cloud is available for RPA or any other application, like for example BPM. The RPA application then sends a data request with input data, for example the mortgage request data, to the API and obtains back the desired output data, in our case the likelihood of an approval or rejection. For companies that aim at the ultimate goal, that is cognitive enterprise automation, the ecosystem consists of more elements than RPA and CPA. They need to consider the usage of other complementary elements such as BPM, Lean Six Sigma, DevOps, and orchestrate them through the process of design thinking as the pacemaker in this ecosystem. An in-depth understanding of these elements, in particular the IBM Watson-based services, will enable companies to embark on cognitive enterprise automation quickly and at relatively low cost. One conclusion that I like to draw at this stage is that finding or designing the most efficient and effective solution or combination in this ecosystem is what defines the competitive advantage of companies now and in the future. Here, an overview of the IBM Watson APIs readily available on the IBM cloud. They can be easily deployed as explained before and provide process management applications such as RPA or BPM with cognitive data. By selecting and combining the proper APIs, an efficient and effective cognitive solution can be built in short time. In other words, the winners of the digital race are able to play skillfully the cognitive keyboard, hitting the notes in the right order and in the right combination. To summarize, we explained the term cognitive and the importance of distinguishing between different cognitive skill levels to design the most effective automation concept. We demonstrated the interplay between RPA and CPA on a fictive approval process to achieve seamless end-to-end automation. We explained additional elements of the cognitive ecosystem to enable companies embarking on cognitive enterprise automation. Thank you very much for your time and attention. If you have got any questions, please contact us.